Hello and welcome to Lesson 5.3, where we will solve quadratic equations by completing the square. We'll also touch on using the quadratic formula, but I think I'm going to split this video into two parts. One where the first part is completing the square only, and then the second video, we will derive the quadratic formula and then use it to solve an example. Okay. So, let's start off with the basics here. I've got example 1 here. I've only got 3 examples I want to work. I'm going to start with example 1, and I want you to notice this is a quadratic equation, ax squared plus bx plus c equals 0, that I'm solving. But this first example is factorable. So I'm going to put this in red. Notice. Oh, come on, little n. I'm going to say, notice, this is factorable. Okay. Now, if you remember the difference of squares identity, right? This is a squared minus b squared equals a plus b times a minus b. So you can factor if you do x minus 6 times x plus 6 equals 0, right? Because this is x squared minus 6 squared. I might even write that because this is x squared minus 6 squared equals 0. Therefore, my solutions, right? My solutions here are x equals 6 and negative 6. So I might box that. And boom, we did it. It's not a perfect rectangle. That bothers me. Let us make that a perfect rectangle. That's better. Okay, so this one we solve by factoring, but there's a second way we could do it. I'm gonna say another method. Let's say another method. And that is to isolate the square and take the square root. The definition more space. Okay, take the square root. Sorry, I know I'm just writing here, but let's do that. If I have x squared minus 36 equals 0, I will add 36 to the other side, yielding x squared equals 36. Now, when you have x squared equals 36, you can take the square root of both sides. Take the square root of x squared. This gives you x. And the square root of 36 gives you 6. But hold on. We have two answers, right? We have 6 and negative 6. So actually, when I do this, when I say, let's cross that out. Let's say, maybe not cross it out, but I'll circle it and say, when I do x squared and I take the square root of that and I say, here's the square root of 36, I must account for the positive and negative solution. I will write plus or minus. And so this becomes x equals plus or minus 30, root 36 is positive or negative 6. Now hold on, what did I just do there? What was that? What was that business I just did? Well, think about this, right? 6 times 6 equals 36. But also, negative 6 times negative 6 equals 36, right? So therefore, the square root of 36, that's going to return 6, positive 6. But both of these examples, right, both 6 and negative 6, when squared, yield 36. So the key takeaway here is, key takeaway. When I take a square root, I must apply a positive or negative answer. This is because when you have x squared equal to something, that number being squared could be positive or it could be negative. But when it gets squared, that result's going to be positive either way. So we're going backwards, kind of saying, oh, well, when I take a square root, there's two possibilities. So I'm branching off into multiple possibilities. Okay, but you may already know this, okay? This may be more or less review, but I wanted to cover just a quick example going over it because it's very important that we understand that when you take the square root of both sides, you must include the plus or minus. This is one of the biggest mistakes Algebra 1 students or Algebra 2 students will make when working with quadratics and solving using the quadratic formula or by completing the square. Whenever they take a square root, you must have the positive or negative answer. It's just something to look out for, all right? Okay, so now let's solve this next one. So we're going to solve this by isolating the square, okay? Isolate x squared. That's our goal. Okay, so I'm going to say here's 5x squared. That's an ugly 5. We will erase that. 5x squared plus 16 equals 0. I'm going to subtract 16 from both sides first. So then I have 5x squared equals negative 16. But then I will divide by 5 on both sides such that x squared equals negative 16 over 5. Now, from here, I want to take the square root of both sides. So I'm going to say square root here and square root here. But when I do this, I must put that plus or minus here, right? Because I am taking the square root. All right, that's a terrible root. Let's try that again. Square root. Love it. Okay, all right. Now, the next simplification process relies on what we did in 5.2, and it's a combination of things. First, this is going to be an imaginary number because I have a square root of a negative. Second, I have to use properties of radicals, or really, which are just properties of exponents in disguise, to kind of get this expression, make it look different, right? To simplify it. And then the last thing I'll need to do is rationalize the denominator. So look at this piece by piece. Okay, I'm going to say, let's actually move over. Let's move this over. And I will say x equals plus or minus the square root of 16, negative 16 over the square root of 5. This is because I can do this with these things. What do we call it? Here, look. The square root of a over b equals the square root of a over the square root of b. Okay? So this and this. You see how I've circled this? I don't know. I hope this is straightforward. I'm probably not doing the best of job of explaining this. I'm sorry. I can split up these radicals using properties of radicals or properties of exponents like so. Now, when I do this, x equals plus or minus. Square root of 16 is like saying the square root of negative 1 times the square root of 16. And this is over root 5. And so I might simplify this as this is I times 4 because we call the square root of negative 1 I. And of course, square root of 16 is 4. Now this is over root 5. However, I need to rationalize the denominator. So I'm going to say I'm going to multiply by root 5 over root 5. Remember, we talked about this in the earlier video. I don't want to divide by irrational numbers if I can avoid it. So I will multiply by root 5 over root 5 so that the denominator becomes an integer. Therefore, x equals, I got plus or minus, and I'm going to just put all this together. 4i times root 5. And this is all divided by root 5 times root 5, which is 5. And now I box that, and we're done. Hooray. And so this is our answer. Now, you can plug this back in, all right? Trust me. You can plug this back in, and it will solve the problem. And notice, so the root of this quadratic was non-real. It was imaginary. I actually would like to show you this. So it's 5x squared plus 16. Let's go. Let's go to Desmos. 5x squared plus 16. Take a look at my parabola here. Notice, are there any x-intercepts? No. This parabola never crosses the x-axis, but that's not to say there's no numbers that make it equal to 0. So, while this parabola for 5x squared minus plus 16 doesn't have x-intercepts, it still has roots. Every polynomial has roots. They just may not be real. Sometimes they are imaginary. Okay? Oh, that's my calculator. Okay, let's move on. So those are those nice 2 solid examples. Now on to example 3, which is going to be the last example for this video, which I don't know how long this is going to take, but we're going to do our best to be timely. Now, example 3. I want you to notice that this is not factorable. So I might say this. Notice, not factorable. Indeed, perhaps this is a good time to explain. Factoring is one of the best techniques for solving quadratics. It's just quick, efficient, and when you're working with other complex functions, factoring just simplifies it in a way it's just beautiful and it's useful. But there are other ways to solve, particularly when something is not factorable. Completing the square is one of such ways. In this video, we're covering completing the square and the quadratic formula, both which are essentially the same thing, and can be used to find the solution to any quadratic. So I want you to, all this to say, we can always complete the square to solve. Always. It does not matter whether the polynomial is factorable or not. This method will work every time, no matter what. It'll give you the real answers. It'll give the imaginary answers. It'll give you the perfect integer roots. It'll do everything. Okay? All right. And you might say, how come it's not factorable? Well, if you do a little cross, here's 9, here's 4. What the heck works here, right? Nothing time, right? There's nothing, you have to do 1 and 9, but 1 plus 9 is not 4, so it doesn't work. Okay. So let's get to solving. So the first thing, and we've covered completing the square before, that's in lesson 4.4 when we traveled from standard form to vertex form. So for the most part, this procedure is the same. All we're really tacking on is what we did in example 1 and 2, where we isolate the perfect square and then take the square root. Okay? So it's kind of, that's really it. Yeah, nothing else to explain there. Okay. Now, I want you to notice that, I'm going to say, rut-row, A does not equal 1. So when A does not equal 1, we need to, I'm going to say rut-row, like Scooby. And I say A is not equal to 1. So I must factor out A. Factor out A from ax squared plus bx. Not the c term. We covered this, okay? We covered this. This should just be review. So let's do that. Here comes the 3. And inside should be left x squared plus, 3 times what is 4x? Well, it should be 4/3 x. You see, because 3 times 4/3 is 4. And then that gives me the 4x. And I'll say here's plus 3. Oops. Plus 3. And then this equals 0. But nothing, actually. There is no but. Okay. Now, there's two ways we can approach this. You can either move the c term over now, or you can balance the equation all on the left side and then move stuff over later. It does not matter how you do this. My presentation is not the end-all be-all way to do this, okay? I'm going to do it the way I like to do it, and then we'll go forth, okay? But if you, I don't know, maybe you found a different way of adding and blah, 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 and you can do that. Okay, now, I'm going to say magic number time, right? I'm going to say, to complete the square, I use b over 2 squared, which in this case, I'm going to say, what does b equal here? Where b equals 4/3. I'm a little slow tonight. I'm sorry. I'm a little slow. So b is 4/3. So b over 2 squared is 4/3 over 2 squared, which is 4/6 squared, which is just 2/3 squared, which is 4/9. If you are not sure how all of that happened, pause the video and figure it out, because it's just fractions, okay? It's just fractions. You can do that. Actually, I just saw a TikTok, I think 2 days ago. 2 days ago, about saying that one of the number one things holding students back in American education is fractions. With regard to math, of course. One of the number one things holding us back from doing algebra, from doing calculus, is just fractions. Can you believe that? You probably say, that sounds right. I believe that. So, again, this is from TikTok, so who knows how credible that is, right? Don't trust everything you see, but I don't know. It seems kind of like it's true. All right. Oh no, Mr. Spake is repeating misinformation. Okay, so let us add 4/9 here. Okay. In parentheses. And then here's my plus 3. And of course, hold on, let's do like that. If I add 4/9, I must subtract. Notice it is 3 times 4/9. And then this equals 0. This is to keep it balanced. I'll try to help you recall that, yes, I've added 4/9, but really what I've added is 3 times 4/9, right? Because that 3 distributes. So I have to multiply 3 times 4/9 to keep it balanced. And I'm subtracting that. Okay. Now, this term is going to factor as x plus 2/3 squared. Let me retry that. X plus 2/3 squared. And then I'll say this is plus 3 minus 3 times 4 is 12 over 9. But really, you could just think of this as 4/3. So this is 4/3, which equals 0. And it'd probably be a good time to just change that 3 to 9/3, right? Because here, I might even underline it for you in green. Plus 3 and plus 9/3 are the same thing, right? But this is to get a common denominator, so it's easy to combine those terms. So then I get 3 times x plus 2/3 squared. 9 minus 4 is 5, so this is 5/3 equals 0. From here, now it looks kind of like the previous example 1 and example 2. I mean, it looks a little bit more complicated, but it's essentially the same idea. I want to isolate this. Isolate this square. And I want to do that so I can take the square root. So I will subtract 5/3 to the other side. And then I will divide by 3. And this gets me x plus 2/3 squared equals -5/9. And that is fraction math you can do. From here, I've got x plus 2/3 squared, so I'm going to take the square root. I think let's do that. So square root of x plus 2/3 squared equals plus or minus the square root of -5/9. Which really this is just x plus 2/3, which equals plus or minus root -5 over root 9. Of course, root 9 is 3, and the root of -5, well, let's rewrite that as plus 2/3 equals plus or minus, this is root 5I, so I would say I times root 5 over 3. And so then I will subtract 2/3 from each side, -2/3 plus or minus I root 5 over 3. And so I'll say therefore, let's make this nice and big, x equals -2/3, -2 plus I root 5 over 3. Plus or minus, I'm so sorry. Plus or minus. And there you go. Now, I will say, technically, you should probably rewrite this as root 5 times I, but that's really more proper, because we always put I at the end. But I just think sometimes this is, be careful, because what if that looks like root 5I, and then that's wrong. So just be careful with that. Okay, let's make our box. Ta-da! And thus it has been proven. Yay! That's the solution. So it's an imaginary solution, which means we can't check graphically. If you wanted to check whether this was true, you could plug it back into the original, square it all out, do all that business, and you'd find that this does indeed solve the problem, making it equal to 0. I'm not going to do that in this video. Maybe I'll do a video on that later or something like that. I'm not sure. I don't know. Should I do it? Oh, okay. You know what? You've convinced me. Why make another video, Mr. Spake? Just do it. Okay. Nike says just do it. So I'm going to say for fun. So this thing, oh gosh. Hello. Oh, everything's going wrong. Okay. For fun. So I'm going to look here. It's 3x squared plus 4x plus 3. Verify x equals -2 plus or minus I root 5 over 3 is a solution to this. One of my classes asked me to do this. I didn't do this for every class, but so one class said, hey, well, how is that the solution? So this is for fun. I'm not going to make you do this on a test or quiz, but you could to verify your solution. I mean, it's a good idea too, but it's just a bit of complicated. I mean, it's just algebra, it's just like busy work. So I don't really care that much whether you are verifying this or not, unless it's just for your own sake. Okay, so The idea is that if I put this number in to this function, it should make it equal to 0. So let's see if that's true. 3 times negative 2 plus or minus I root 5 over 3 squared plus 4 times negative 2 plus or minus I root 5 over 3 plus 3 equals 0. Now I'm going to do some tricky business here, okay? I'm going to do some tricky business. So this first term right here, I'm going to factor out a third, kind of in a creative way, okay? So if I do this, this is like saying 3 times 1/3 squared times negative 2 plus I root 5 squared. And that's using a property of exponents because it's just 1/3 times negative 2 plus I root 5. I'm writing plus or minus, aren't I? Plus or minus. Okay. And so that's good, right? I can do that just fine. And then I'm going to do the same here, plus 4 times 1/3 times negative 2 plus or minus I root 5 plus 3 equals 0. And now this term right here, right? Maybe I'll just bracket it. 3 times 1/9 equals 1/3. So, how do I do this? This 1/3 and this 1/3 can be factored out as 1/3, and I'm going to use big old brackets here. And then I have negative 2 plus or minus I root 5 squared plus 4 times negative 2 plus or minus I root 5 plus 3, but 3's at the end, so I'm going to do that. I say plus 3 equals 0. Okay, you might be saying, why is Mr. Spake doing this? It's to save myself the trouble of doing math with fractions. I could, but that'd be disgusting. So I actually get really lucky here that 1/3 is just factorable, you know? It's just a common term. So I pull it out because that's just easier. Now, to simplify this, so I'm going to keep that 1/3 in my big old bracket here. Let's write a little stipulation. Let's switch to green. This fella right here. Okay? Or maybe I'll do like a little star. This guy. I'm going to move over here. Negative 2 plus or minus I root 5 squared is negative 2 plus or minus I root 5 times itself. You know what? I know this is going to add to the runtime of the video, but I just can't help but just think that all is hideous. I mean, it's just aesthetically discomforting. So I'm going to rewrite it so that it is... I mean, I don't have the best handwriting. So for me to say that is hideous really means I do not like it. Okay. So let's distribute this. Negative 2 times 2 is 4. Then this is minus 2. Well, it's really like plus or minus 2I root 5. And then I do it again, and it's plus or minus 2I root 5. And then it's, well, positive or negative actually doesn't matter because a double negative will cancel. So it'll be plus I squared times root 5 squared. And so if I do all of this, I get 4 plus or minus 4I root 5. You know, it would be better to rewrite this as minus or plus, That would be more logically consistent, minus or plus, and this will be minus or plus. And then I squared is -1, and root 5 squared is 5, so this is like saying minus 5, which actually just simplifies down to -1 minus or plus 4i root 5. I'm going to circle that. Okay, so if I come back here, and I squared that whole business out, I'm going to get -1 minus or plus 4i root 5. And then if I distribute this 4 here, I get -8, and then plus or minus 4i root 5. So now I can actually condense this a little bit and say plus 3 equals 0. Okay, are you seeing it? Also, are you seeing why I wrote it as minus or plus? Because what's going to happen... Where's my highlighter? Highlight. Let's do highlight in green. This guy and this guy are going to cancel. All right? Let's do it in black. Cancel each other. Because look, if I put in the positive one, then it would have been negative, it would have canceled. If I put in the negative one, then the result would have been positive, and that would have canceled. Okay? Because I'm I'm being a little sneaky here, and I am, how do you say? I'm doing two solutions at once, which isn't really allowed, but I'm doing it anyway. Okay. So then I do this, I got -1 minus 8. Well, that's just 9. So this is 1/3 times -9 plus 3, which hopefully you can see by now this is -3 plus 3 equals 0, which means 0 equals 0 is true. So hence that is the solution. Hence our solution is true. And I'll put a little happy face like that. Okay, and there you go. I just thought this would be fun to tack on near the end of the video. You don't have to do this, but I guess there's some value in doing this, just evaluating the expressions and getting that algebraic practice, you know? It's good algebraic practice is all. This is some of the stuff you'll have to do in calculus, and it's going to be annoying, but it's good. It's just good practice. I don't know what else. I just sound like a broken record. Okay, well, that ends this video. That's all I've got for now. Part 2, we're going to go over the quadratic formula. All right, so hopefully I will see you there.